There's something about trigonometric identities that just seems to throw people for a loop for the first time. And really, all it is that we are solving equations, but we're solving them in such a way that we are showing that it works not just for one x, but for every x. And that's why we call it an identity. For example, one of our identities that you should be aware of by now is that the sine squared of x plus the cosine squared of x is equal to 1. We remember this from the unit circle. The sine squared is equal to y squared. The cosine squared is equal to x squared, and that's equal to 1. This is true for any y and x on the unit circle. That's the definition of the point on the unit circle. So we have this basic identity here that we are going to pull from a lot. Well, variations of this I think you've already seen as well, that the sine squared of x is equal to 1 minus the cosine squared of x. And similarly, the cosine squared of x is equal to 1 minus the sine squared of x. All we're doing is subtracting one of these two and moving it over to the other side. What I'm excited about getting into trig identities with you is now at last you have the opportunity to get your algebra right. You're going to have to do things legally. You're going to have to forget the cheap cancel, the quick flip, tricks that you think are right, but you don't know why they work. Now you're going to have to do things very legally. But the thing to remember with identities is identities, they're called that because they work for all x. We're not just solving for pi halves or 3 pi over 2 or something like that. Everything, it'll work for it. So, without further ado, let's do one. We want to prove that the cosine of x times the secant of x over the tangent of x is equal to the cotangent of x. Now the last thing I want to do with an identity is treat this as an equation and multiply through by the tangent of x. No. What you are going to do is you're going to take this left-hand side and manipulate it until it gets to look like the right-hand side. And then you're done. So I'm going to do that. I'm going to reduce all cosine and secant and tangent to sines and cosines. That's one of the tricks that you'll practice early. And I'm going to rewrite this as cosine of x, that's already there, times the secant, you recall, is 1 over the cosine, and the tangent is the sine of x over the cosine of x. Now I have rewritten this left-hand side into all sines and cosines. And it's kind of nice. I don't have any pluses in here. I don't have any minuses. Everything is being multiplied or divided. So I have cosine of x on top, cosine of x on bottom. I can cancel. And I'm left with 1. On the bottom I have sine of x over the cosine of x. And if you know from your algebra, when you have 1 over a fraction, the fraction is simply the denominator flipped. That's equal to the cosine of x over the sine of x. Now, if you don't believe me on that, let's take 1 over the sine of x over the cosine of x and I'm going to multiply by the reciprocal, which is cosine of x over the sine of x. But if I do that on the bottom, I have to do it on the top. Cosine of x over sine of x. Cancel, 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 cancel. All I'm left with in my denominator is 1. On top, I have cosine of x over sine of x. And we are done because that is that. So we have worked the left-hand side until we made it look like the right-hand side. That's how to verify an identity. That's how to prove an identity. That's how to do it. So have fun, watch your algebra steps, be very careful about slick tricks that you think you know from the past.